Hey, hello. You're stuck in traffic with Wolf Gorlick. Couple-minute riff on IT and IT security. Today, looking at the controls that can protect industrial control systems. So, I am stuck on the highway, headed out to meet with a client at 9 o'clock, where we're going to kick off a controls assessment before doing some penetration testing. And as you guys know, I'm a big fan of control frameworks. I like to know a big picture, where the controls are, what they need to do. I'm not a big fan of necessarily saying, okay, let's make sure we tick all the boxes, because I think you need to lay the controls out along the lines that attackers are going to take to get at key systems. So the tip to you is start with a good threat model and work your way back with detective and preventative controls. So for example, let's suppose we had a manufacturing plant. Let's suppose in this manufacturing plant we had an attacker who was looking to disrupt the plant. And the attacker is going to do a couple things. He's going to walk into the plant. He's going to plug in a device in the network. He's going to have that device dial out to a more sophisticated attacker, who's then going to use that device inside the network to launch an attack against some of the very sensitive industrial control systems. And as we know, industrial control systems tend to be older. There's a high number of vulnerabilities. 1 in 10 of them are susceptible to denial of service. 1 in 15 of them are susceptible to product manipulation. So in other words, you can manipulate the codes causing the devices to malfunction. So broilers are not hot, coolers are not cold, and robots are not where they're supposed to be. So they're going to do some disruption, and that, in a nutshell, is the attack. So what do we do with the controls? We just do like all the critical security controls? Do we just like lay everything everywhere? Well, maybe. But as with any company, a manufacturing plant is very cash sensitive, right? Very budget driven. So let's follow this path and see what controls would go where. Let's start with walking into the plant. These are physical controls. Do you have locks? Do you have guards? Do you have cameras? Are you checking badges? Are the badges rotated for guests? Are guests escorted throughout the building? Those types of physical controls, right? Next one, plugging a device in the network. Now we're talking about some network controls. There is a physical component to it, such as, for example, putting some cable locks so that people can't get to the cables, or unplugging patch cables that are not in use in key areas. But you also have network access controls where you say, hey, if this device does not meet this particular MAC address, don't allow it on the network. Can it be bypassed? Absolutely. But it does raise the bar for the attacker quite a bit. Now, the next thing is the device beacons out. So there you're talking about good egress filtering, IPS, IDS monitoring, looking for those beacons back and looking for that attack signature traffic. Then the attacker is going to scan and try and move from that device into the manufacturing and the production network segments. So here we're talking good network segmentation, and I don't just mean a VLAN with some routing. I mean true segmentation where you've got firewalls between these devices. IPS, IDS again, you're looking for scanning behavior. You're not allowing the device to talk to another device, but rather you're whitelisting the traffic so that only certain SCADA systems can talk to certain ICS systems, right? This machine can talk to that pump, those types of things. And finally, when they get to the box, disrupting the system. DDoS, or denial of service, not distributed, product malfunctions, those types of things. There, what you need is host-based hardening, wrapping around these legacy computers, oftentimes Windows XP and Windows 2000, sometimes even DOS. But let's stick with XP 2003. Wrapping around host-based hardening such that those attacks get deflected and are not successful. So putting all that together and then having a good monitoring program where you got someone watching 24/7 for signs of attack on the network access, on the egress on the firewall, right? On the scanning internally, on the host-based hardening. Having a control around it means that we, the good guys, don't need to get lucky once. the bad guy now has to get lucky every single time, every single one of those steps in the attack path, right? He's got to evade the guards, he's got to evade the cable locks, all that sort of stuff, which gives us a fighting chance. It also means we now reduce the areas that we have to put controls on to just this particular path, thereby being more cost effective. So there you go. There's a good way of laying out how you would distribute and design a manufacturing system security program. Catch you next one.